Okay, so at home this week, you're just watched a short ed puzzle. The guy talked kind of fast, but he did a decent job explaining how you can use Desmos to make line of best fit or line of regression, or like you called in science class, I think you called it a trend line. So the last part of this chapter has us writing equations one more time, but writing equations for real world applications of making a trend line, which are line of best fit or line of regression, which helps us make predictions in real world situations. So I'm going to make this video is going to show you one more example using COVID-19 data that I use with kids in the spring. It's very old data, but it's good for an example. And then you're going to try to do this on your own with some of your pumpkin data that you collected with Mrs. Boyle. So basically, here goes. So this is Desmos, all right? So remember that guy's video. I just watched it myself too, so hopefully I have this pretty fresh in my head. So what you're gonna do is, this is my data, okay? So this is way back March 25th, okay? Days since March 25th is my X. My Y is my number of cases. Wow, we only had 68,000. Now I think as a country we've had like over, what is it, like close to 10 million cases. So that is ridiculous. So anyways, I'm just gonna do the first 20 days. I'll go up to x equals 20. So I'm gonna, just like that guy did, I'm gonna copy this here. And I think I realized it works better if you do Command C. I'm gonna press Command C. Then I'm gonna go over to Desmos. I'm gonna go into this cell. I'm gonna press Command V. Yay, it worked. There's my data. So that, I didn't include the titles. I didn't feel like that was necessary. Cool little thing. You can see it kind of looks linear. So line of best fit would work here. If you click this, if I remember correctly, there was a way to make it, oh man, there was a way that you could, can't remember, but there was a way you could connect the dots to make it, more like a line plot, if you will. Can't remember right now. So anyways, this is, you can see from day 0 all the way up to day 20, going up to, looks like, I don't know, a little less than 10,000 all the way up to 60,000 and change cases per day. So if I wanted to make a line of best fit, if you remember the guy's video, you go to the next cell, and then what you type in for line of best fit is Y1. And then instead of equals, you put the squiggly line, which is above or below the escape button. You press shift, and then it's the approximation. So in math, that means like approximately. So that's why it's like your line of best fit is approximately the line that would be best fitting this data. So then you would put your slope M, and then you press X1, and then you put plus B. There it is. There is my line of best fit. Okay. It gives us all this data, so you can see the closer this R number is. I'll zoom in on it right here. The closer this R number is to 1, the more correlated it was. So this seemed to be pretty linear at the time. You can see that the slope is about 28,000 cases per day back then, and it started at about 35,000 cases. So if I wanted to then go ahead and let me just zoom back out. If I wanted to, say I wanted to just plug in that data, so I'll take the line off. If I just wanted to graph that equation, I would write y equals, my slope according to this is 28,566.1 x plus 35,942.2. So that's my line of best fit, and that goes, is it the same? Yeah, really, if you graph both, one on top of the other, it's the same exact line. So then he did something cool here. I don't have that option. On his video, he was able to edit list. Let's see. Yeah, that's pretty cool. If you press edit list, I'll do it again. So you go up here to the little wheel, and you press edit list, and then you press table. Look at that, right? it'll give you a table. Let's see if this prediction was anywhere near correct. So see if I can do some quick math in my head. So this started, this data at least started us off in March 25th. So we'll add some months here. So March, April, May, June, July, August, September, October. 25th is 7 months. 7 times 30 is 210. Then maybe you're like 10 days into. So let's put 220 in for X. So I'm curious what the model would predict if we went 220 days in, if it's anywhere close. 220 in for X. Whoa, that is a huge number right there. So that actually means move the decimal over 6 places to the right. So that's 6320484. 1, 2, 3, 4, 5, 6. This is actually saying, wow, it's saying 6 million cases, 6,320,000 cases. So that model obviously was way back in the beginning of the pandemic and is not 100% accurate. So we are more at like 2 million cases. So that's if things were spreading at that rate of 28,000 cases per day. And there's times where it was close to that rate, and there's times that it was much lower or much higher than that. So your challenge here today is to do the same thing with this pumpkin. So this is an example right here. Someone was nice enough to give me their pumpkin data. So this person was looking at circumference and number of seeds, and they came up with this. So your challenge is to do the same thing here on Desmos, right? And take a screenshot of your work here. Trying to see if there's any way to make this smaller. No, so even if you just screenshotted your work, and then, so if I was doing this, I'd go Command-Shift-4, screenshot my graph, and then maybe I'll have you type in your line of best fit equation. So then I would post this to the form, and then I would write this equation here with my slope being 28,566. So the equation basically that, if I go back down here, I don't want to lose it here. Will I X it out? Will I lose it? Yeah, I lost the equation. But the one I wrote here, that equation, see if you can write it out. So I'll write it one more time. I would write y equals 28,566.1x plus the 35,942.2. So good luck. Hopefully this video will get you going, and you're again going to do your pumpkin data.